Hello Professor Reza and everybody watching this video. Today we're gonna do k-means clustering, basically assignment 5, and let's understand a little about k-means clustering before we head into it. So k-means is generally an unsupervised classification of data. So machine learning, unsupervised machine learning classification, that means wherever there is a lot of data, we don't know what to do about it, and we want to classify the data into maybe unnamed labels or unknown labels, unknown groups, but we want to see whether the data is in groups or not, is where k-means clustering comes into picture. But we also use k-means clustering where we know labels, or basically supervised machine learning, and we're gonna try one example of k-means clustering in supervised data, and it's gonna be our assignment 5. So let's understand assignment 5 before we jump into it. So Mr. John Hughes is looking for some help understanding clustering techniques using the k-means model using this data set from the last assignment. It says the data set has 6 independent variables and 1 dependent variable. This is the data set: 6 independent variables, 1 dependent variable, which is a boolean, which means either the cancer patient is showing remission or not. And let's go ahead and see what the code is, basically how we can code it. So we have used Colab here, Python. So for machine learning with Python, we need certain libraries like pandas, numpy. To plot, we use matplotlib, and we want the k-means class, since we are going to make objects from the k-means to make our model, and we need silhouette score from metrics, which we'll come to know soon in this video about how we use silhouette score and why we use it. So this is where we imported the data set and printed the first 5 rows just to see whether it has been imported correctly. And we create our x, that is the data frame of the independent variables, by dropping the dependent variable and converting it into a numpy array. That's our x. We then standardize or scale down the values in the data set, since machine learning algorithms work better with smaller numbers rather than bigger ones. Then we come to something called, so in the k-means model, we have to tell the model what are the number of groups we should classify the model in. So now this is a tricky part. We have to tell the model how many groups we want to see in the data, and for us to understand that, we need to know about certain metrics. Let's come to WCSS first. WCSS is within cluster sum of square. So as mentioned here, WCSS is nothing but the sum of squared distance between each point and the centroid of a cluster. So what does this mean? When we are creating a k-means clustering model, we have to tell the model how many clusters do we want. So we pass that as a parameter, and the model then, what it does is it creates, suppose we say we want 2 groups, it would just plot 2 points on the plot. Then it would put in all the data points, and then what the algorithm does is it measures the distance of each of the data points from the randomly dropped in centroids, and sees in which group or basically groups the data points according to the distance of these points from the centroid. Now if we had to picturize this a little better, what we can do is go here, and let's not consider these as green and red. So when the model is starting to do its work, it would just put these two centroids, or maybe it would have all the points, maybe all of them are black at this point, and it would drop two centroids and then measure the distance of each of the points from the centroid to make the initial grouping. As in, if we check the distance of this point from this centroid, it is really far compared to this point from this centroid. So all the points which are closer to this centroid than as close as they are to these points are gonna be in one group, and the points closer to this centroid are gonna be in one group. So that's how the algorithm really works. But then coming again to the tricky point, how do we decide the number of clusters there is when in this case it is probably easier because we know that the data has two labels, either remission or no remission. But that means in our data there we have to group, it's not that there are two groups, but it's more about we have to group the data into two clusters, that is remission or no remission. But when it comes to unsupervised machine learning, where we don't know how many labels are there, whether there are even labels or not, whether we can classify this data or not, how will we decide how many clusters are there just by looking at the data? So this is where WCSS comes into picture, and there's this metric called k-means inertia, and what inertia tells you is how good is the model doing. So the lesser the WCSS, the model is good, and we use the inertia of the k-means to plot a graph called the elbow chart. So how do we do it by code? Is this way. So we have created a list called WCSS, then within a for loop ranging from 1 to 10, we're going to make instances of the k-means class, passing the number of clusters from 1 to 10 with the other parameters remaining the same: init, max iter, init, and random state. And what we're going to do is we are going to make instances of the k-means for all the values of all the different values of number of clusters, and then what we're going to do is pass our data into it and then check the k-means inertia, and we're then going to plot the k-means inertia into a plot. And what we see is, from this, how we come to know what should be our number of clusters is the elbow. We have to think of this line as a person's hand, and we have to see where the elbow may be. An elbow, that means it should be a sharp change, or basically a change that is sharper than the rest. So if we see for this one, the elbow method tells us that 2 is the number of clusters, which is actually right in our example. Then comes silhouette coefficient. This is again a metric which tells us how well our model is doing based on the number of clusters. So again, what we do is we pass n cluster from range 2 to 10 within a for loop, and we create multiple instances of k-means, and we use the silhouette score that we get from the silhouette score function measuring Euclidean distance between the points, and we, we, we print all of them and then plot the silhouette scores in a plot. And here we have to check the point with the highest silhouette score. So here we see 2 is a peak, we have 5 as a peak, and we have 7 as a peak, and the highest one is 7. But in our case, since this is a supervised application and we know there are only 2 labels, we're going to stick with 2. 2 is going to be our number of clusters, and we pass 2 as the number of clusters in the algorithm that we want, and this is our model. We fit predict the data transformed, and then we will plot. We will in this step, what we're doing is we are just assigning labels based on where the points are falling, and this is done with the help of the model we just created. And now in this step we plot the model, and this is how our model looks. So as we see, we have, as we wanted, we have 2 clusters of data. That is, one is the red cluster, this is cluster 2, and the green cluster, that is cluster 1. As we can see, the lower the y-axis, y coordinate of the points are, they lie in cluster 1, and comparatively higher values which are closer or higher or maybe positive values are within cluster 2. So this is how we have been able to create 2 clusters and segment the data into 2 clusters or 2 groups. And that's about it for this assignment. Thank you very much.